All right, I think we're live and sound. So, yep. So, welcome to another stream. This is Programming Everyday Until I Land an Intern number 7. Today, we will be doing select system call in C. So, without further ado, let's start. So, here. So, so basically, let's first read what select is from the slides. Um, so, select. So select is used for I/O multiplexing, which is basically multiplex the input-output um, file descriptors, right? So it's related to the file descriptors. So if you specify this, if you specify this and this, basically whatever you specified, read FDS, write FDS, accept FDS. So select will return when any of the file descriptors that are set using fdset read fds, fdset write fds, fdset accept fds are ready. So any of this, if it is ready, then the select system call will be returned, right? And int n is the max ft plus one value, basically um, among read fds or write fds or accept fds, whatever you set it to. Among those file descriptors, whichever is the maximum, you add plus one to it, you add one to it, and that will be n. So um so select will return if either read fds or write fds, one of the values of one of the file descriptors of read fds set or write fds set or accept fds set is returned, um, or when the timeout has occurred. So if you want to read the man page for select, let's just read the man page for select just for our sanity. I think it's a system call, so it will be 3. Sorry, man 2, right? Yep, system call is 2, 3 is library functions, but anyway. So sys socket.h is sorry, sys select.h is where it is. So I don't know why. Where did we select? It's okay. Well, you have to use select.h to include sys slash select.h, and so let's just read the description. The function signature is this anyway. So select examines the IO descriptor sets whose addresses are passed in read FDS, write FDS, and FDS to see if some of their descriptors are ready for reading or ready for writing or have an exceptional condition pending, respectively. The first NFDS descriptors are checked in each set. The descriptors from 0 through NFDS minus 1 in the descriptor sets are examined. If you have set two file descriptors 4 and 17, NFDS should not be 2 but rather 17 plus 1 or 18. That's what I explained earlier. On return, select replaces the given descriptor sets with subsets consisting of those descriptors that are ready for the requested operation. So replaces the given descriptor sets with subsets consisting of those descriptors that are ready for the requested operation. So which means that if one of the values, if one of the file descriptors is ready in read-fs, then that particular file descriptors will that particular file descriptor will be present in read-fs when the select call returns. So I think that's what they meant. So the descriptor sets are stored as bit fields in array of integers. So bit fields in array of integers. Okay. The following macros are prepared for manipulating such descriptor sets. So fd0 and fd set initialize descriptor set fd set to null set, fd set which includes a particular descriptor fd in fd set. Fd clear removes fd from fd set. Fd is set is non-zero if fd is a descriptor, is a member of the fd set. Zero otherwise. Fd copies basically represent an already allocated fd set copy file descriptor set with a copy of fd set or original. So represent already allocated fd set copy file descriptor set with a copy of fd set orig. Interesting. The behavior of these macros is undefined. I don't know why is this. Fd copy is replaces an already allocated fd set copy file with a copy of fd set org. So this original will be copied into the fd set copy. Okay, so with a copy, so fd set original um, will be copied and set to this fd set copy. Understood? The behavior of this macros is defined if a descriptor value is less than 0 or greater than or equal to fd set size, which is normally at least equal to the number of maximum number of descriptors supported by the system. Okay, that's cool. Okay. If timeout is a null pointer, it specifies maximum interval to wait for the selection to complete. If timeout is a null pointer, if it is not a null pointer, this specifies a maximum interval to wait for the selection to complete. If timeout is a null pointer, this select blocks indefinitely. To affect a poll, the timeout argument should not be a null pointer, but it should point to a zero value time while structures. Timeout is changed by select and may be reused in subsequent calls. However, it is good style to reinitialize it before each invocation of select. Any of read FDS, write FDS, and write can may be given as null pointers if no descriptors are of interest. Yeah, so the timer is now not changed by select and may be reused in subsequent calls. However, it is good style to reinitialize it before each invocation of select. Okay, return values returns the number of ready descriptors that contain the descriptor sets, or -1 if an error occurred. So if the time limit expires, select returns 0. If the select returns with an error, including 1, due to an uninterrupted call, the descriptor set will be unmodified and the global variable no will be set to indicate the error. Okay. Alright, so E again, E bad of, so invalid descriptor, in bad file descriptor, int r inval. Nice. You can just use this, or you can specify this systypes.h, systime.h on unisted.h. So okay, right, so this is the man page for select, and which is pretty cool. Right, that's nice. So okay, now this is the example program showing use of select. So main argc, that's okay, conft rset. So you're defining a file descriptor set rset, open socket and no caption connection as earlier. And after this, fd0, you're putting fd0 and rset. Okay, so you're initializing this thing to 0. So that's what it is. Initial descriptor to null set, and then fd sets, you're adding stdin to the rset. You're adding conft to the rset. Conft is returned when you call accept. So after that, you do max fd is equal to max of stdin conft plus 1. That's cool. Select of max fd rset. You're not interested in rset, which is the reading set or whatever set you have, and you specify null here for write sets. You specify null here for what is this, exception, and you specify null here for timeout. So there's no timeout. It will block indefinitely if none of this is, if none of the file descriptors among rset is ready. So if fd is set, stdin rset input from stdin, else if okay, after it returns, this is the thing, um, yesterday and R said that's cool, else printf error, that's cool. So these are the conditions when read descriptors are ready or write descriptors are ready. So read descriptors are ready when number of bytes in the descriptor is greater than low watermark for the socket. So when the number of bytes in the descriptor are greater than low watermark for the set. That's cool. Okay. Then low watermark for this socket. So like if the descriptors is there and you're reading from it, you can only read from it when the number of bytes in the descriptor are greater than low watermark for the socket. Okay, that's cool. So when the read end of the socket is closed and therefore EOF is the result. When the read end of the socket is closed. Interesting. So when the read end of the socket is closed, and so if the read end of the socket is closed, then obviously um, I don't know, I'm not too sure about it. When the read end of the socket is closed and therefore EOF is the result. It is a listening socket and the compute queue is not empty. And the socket error is pending. Alright, yeah. Not too sure about this. And then write descriptors are ready when number of free bytes in sockets and buffer is greater than low watermark. By default, this is 2048 bytes for TCP and UDP. Write other connection is closed. Write to the socket will generate a SIG pipe. Socket is pending. I think this is more of the theory part, and I don't think it's required for as of now. But we'll read this after when we do the theory part um, for network programming later in one of the streams. I think that's all for select. Now let's implement iterative echo client. Let's implement iterative echo client using select. So think about this. So this is the client. So this is the server. I'm sorry. So this is the server, and it's quite a long code, but it's pretty simple. So what are we doing here is basically the purpose of this is that we need to um, make an iterative echo client server using the system call of select. But usually without select we can do iterative echo, but it only serves one client at a time, and so it is not concurrent as the name suggests. It's just iterative, one client at a time, and then after the client has been serviced another client comes in. So but if we need to do an iterative echo client, we need to use select, um, which basically serves the purpose of monitoring the socket for if they are ready. And I'm not too sure about it, so I'm not really sure about this. So let's just read what is the code. Implements a TCP echo client server using select system code to manage multiple client connections. That's what it is. The server listens for incoming client connections, handles client communication, and echoes back the data to send clients. Here's a step by step breakdown of how the code works, but it's okay. So let's see server.h. All the import statements or the include statements. I'm sorry. stdio, string.h. Let's just do this. String.h, unist.h, sys socket.h, types.h, in.h, net inet in.h. It's not really required, but it's better to include it. alpha/slash inet.h, sys/select.h is where we have include this. Sys/socket.h, unit std.h string.h. Okay, that's cool. Now we're doing max line. Max line is 10. Max line is the buffer size 1024. We're setting as 1024. Argc, argv. This is the main function. It's pretty standard because it's two usages, just the file name and the port. That's cool. Exit one and listen ft. So we're doing because for server we have two file descriptors. Listen ft for listening for client connections, and connect confd after making the connection. So sock fd, max fd, and ready. So that sock ft. So this is the new thing that we have. We have a max fd also. We have and ready too. So int clients, max clients. So we are doing an array of clients, okay, which is of type int. Interesting. Struct sock adder in server address client address. This is just standard. Car buffer max line. This is also standard. And then we are going to the meat of the part. Fd set, all set, and not set. So where is it? All set and R set. Okay. R set is for read set. When basically monitoring for read descriptors. All set. I'm not too sure about this. Socklen t sklylen. That's okay. Size t, and this is also okay. Initialize client array. So you basically initializing client array to -1. So the client array, you are initializing all of them to -1, which means that initially there's no client connected. Now when you're creating a socket, this is just standard. It's just socket of af inet sock stream 0. Af inet sock stream, this is tcp, and 0 is just for think about this. Sorry. Okay. You are basically initializing server address using memset, setting all of it to 0, memset, and server address 0, and size of server address dot sin family is afinet. Okay, sin address s address h2nl in address any. That's cool. Sin port is h2ns a2rv1. That's cool. You're binding it, and then after that you binding it, binding the on the listen of the struct sock address and server address, size of server address. That's cool. And if it fails, period bind, close listen ft, and exit one. Listen of basically you're listening maximum for 10 clients. So that's why you have specified 10 here. You can just write max clients here. That's just an implementation choice. And if it fails, p error, close and exit, and then printf server listening on port. Server listening on port percentage argv1. That is interesting. argv1 server listening on port. Okay, after it starts listening, now you initialize the fd set, fd0 and all set, fd set, listen fd, and all set. So you're initializing the fd set here. So your fd0, you're making a null set, all null set on all set, and then you're adding listen fd to the all set, and you're setting max fd to listen fd. Interesting. After listening, and then while one, which is constantly listening for new connections. Basically, if there's a new connection on listening socket, you're doing all set, copy all set to R set for select. Okay, I got that. And you're calling select here, max fd plus 1, R set, null, and you're counting how many are ready. This n using n ready. Oh my god. Okay. If n ready is less than 0, PR is select break. Okay, that is break. You're using break here, which means you have to go just to the next line out of this loop, and let's go to the next line right here. I think so. And check if there's a new connection on the listening socket, and then you're checking if there's a new connection on the listening socket. So if FD is set, if listen FD is part of the R set basically, which means that it is ready. Then you do client length and then you accept it. Okay, okay, that's cool. So you are using accept system call on the listen FD, and then if confd is less than 0, PR accept and then continue, which means that you need to continue to the um, next iteration basically. Okay, okay, all right. So and then you're doing printf new client connected from percentage s percentage d percentage s is basically from this address. So inet into a, which is network byte order to presentation basically. um that is understandable. One second boys. I'm back. So again, so you're checking if there's a new connection listening socket, and then I need into a on port basically. You're getting port through N2HS, obviously. N2HS network to host on the port address, client address dot port. Interesting. And then after, because this client is connected, you change this um, I mean, if it is less than 0, you change uh, the next client um, value, which is -1 in the array. You change the next thing to um, to this value, which is confd, whatever the confd returns on accept system call, whatever it returns. You set the confd value to clientify, and then you break, which means you have to do it only once, and then school. Okay. And then if I is equal to max clients, and then if yeah so if I is equal to max clients, f printf too many clients on the standard error output stream, and then close the confd. Else you set confd and all set. So you add confd to the all set. Remember that all set we already have we already have listen fd here, and you're adding confd to the all set. Okay. And then if confd is greater than maxfd, we use maxfd is equal to confd, which means confd you're setting into max FD. That's cool. And then you're doing if after decrementing end ready, if it is less than or equal to 0, continue, which means no more descriptors to process. End ready is where you have this, which means that after decrementing end ready, if it is less than or equal to 0, no more descriptors process, which means no more clients to process. uh, yeah, basically no more clients to process, I think it is what it is, right? And then continue to the next iteration. You can do, you can start off from here. um let's say if conft is added to the all set, so our set now contains listenFD and conft. And if confd is ready, which means end ready will be 1. If end ready is this is okay, this. And then listen, if fd is set listen fd, but listen fd is not there, so you just skip this part. So okay, but but naturally if confd is ready, then obviously listen fd is also ready, and not the other way around. And then after you do this, check if this is a new connection listening socket. After you do that, you um, basically check all clients for incoming data. So in the client array, you basically, if client I, okay, you set client I to sockfd, and if it is less than 0, continue, which means continue to the next iteration. Which means if it is less than 0, if client I is less than 0, which means it is not ready and the client is not um, connected, that means you should continue to the next loop. But if it is greater than 0, then that's cool, sockfd is initialized to some value. And then if fd is set, sockfd is part of our set. It's a little confusing. If fd is set, sockfd, if basically this says that if sockfd is part of our set, so what does that mean? If the sockfd is part of our set, oh my god. If what if sockfd is part of our set? Hmm. Okay, which means if the socket is ready. Okay, that's okay. Okay, okay. So you're checking if this socket you have if you're checking if the client you have retrieved in sockfd is part of our set, which means if the client is ready for reading. Okay. And when is it ready? When the when the select system call returns. And when the select system call returns, it basically sets the here basically sets it here when it returns, right? uh, okay, yeah, okay. I'm not too sure about this. I have to read it again using ChatGPT. But if an so when the client is ready, You read from it. It's basically standard. If n is equal to 0 and number of bytes is less greater than, I mean, if it is 0, then it's client disconnected, and if it has a 0, clear read. And then you have to close sockfd. You have to clear sockfd of the all set. Okay. Basically, you're never adding sockfd to all set, but interesting. Client is minus one. Else buffer of n is, and you basically null term it in the string, and then you're printing out this, and you're writing back, which is echoing back to the client. And if n ready or this is okay, and then if you're you're decrementing n ready again, um, if less than or equal to 0, which means break, go to the next iteration. Come out of the loop. Yeah, just come out of the loop. It's no more descriptive process. And while we're still in while though, after that, after this, if this condition is satisfied, you have to break, close listen of d, and then return 0. Oh my god. But it's certainly interesting, but it's still not really clear to me what the code is trying to do. So let's try to understand it again. Let me charge my laptop real quick. Okay, so we have a readme here. Readme 2 is, I think it's better. So let's just put it here. So multi-client server using server to handle multiple client connections, single-threaded manner. Okay, in a single-threaded manner, that's cool. Here is the best of roadmap. Command line arguments, cool. Data structures and variables. I think it's just better to do this way. Damn it, I'm sorry. Command shift V. Okay. Okay, so the program expects this client max client. Now this is the data structures. Here is the data structures. This client of max clients stores the client socket descriptors, initially -1 for empty slots. Okay, client socket descriptors. FD set, all set basically tracks all active file descriptors. All active file descriptors. Temporary copy of all set, user select. Oh, it's just a copy. It has no value, I think. There's no significance, I think, R set. It's just a copy of all set. I mean, that's what we're doing here. Interesting. And then we're doing max d tracks the maximum file descriptor value for select. Tracks the maximum file descriptor value for select. Tracks the maximum file descriptor value for select. That's cool. And then socket installations, listening socket, that's cool. Is created using socket. Socket is bound to the given port using bind. Listen marks the listening socket. Address structure. This is also serves an address and port configured for IPv4, IFINet, initial file descriptor sets, FD0. So, okay, after this, FD0, you're clearing all the bits in the all set. That's cool. I remember all set is just used for tracking all of the active file descriptors. FD set, you're adding listenFT to listening socket to the all set for tracking it. Then server loop, the main server loop runs indefinitely, performs the following steps. Wait for events, select. Waits for an event, readable data or new connection on any socket and all set. Okay. Okay, that's cool. Blocks until at least one event occurs. Handle new connections. FD is set, and then your so basically the main server loop runs indefinitely. The while loop basically and performs the following steps: wait for events, select, and then handle new connections. After that, basically you're waiting for it, and after you get it ready, um, you're handling new connections by using if FD is set, if the LSN FD is part of FD R set, or you can just use okay, R set is better. True, true. And then checks if the listening socket listen FD and checks if the listening socket listen FD is ready. That is cool, indicating a new client connection, which means it is ready to accept things, indicating a new client connections. Okay, that's cool. And then you can accept this call to accept the connection. That's cool. The new client's file descriptor concept is added to the client array. The new client's file descriptor, the new client's file descriptor is added. ConfD is added to the client array. Yeah, just setting the client array to ConfD here, which means here just doing that. Um, added to all set for monitoring, and then also added to all set for monitoring. Okay, okay, okay. I got that. Used to update max FD if necessary, and then this is FD set. Um, okay, that's cool. And used to update max FDs if necessary. That's cool. Okay, okay, nice, nice. So if client is full, the server closes the connection and logs an error. So here, if the client is array is full, basically, um, he has too many clients and stuff and closes. Now after that, after this, the C part is process data from clients loop through clients. Okay, process the data from clients loop through clients. You get the sock fd, which is the confd basically. The sock fd is actually the confd, uh, where you've set it here. And this thing, you only check for the socket is basically confd, and it is only set to confd if the connection is valid. So you're only dealing with the connected clients, and because you added confd to all set right here, you can also check confd to r set here. Amazing. So that's what he's saying, right? Through clients. Oh damn. Each client socket is checked for incoming data using FDS set. Nice. If data is available, each client socket is checked for incoming data as using FDS set. Nice. If data is available, read data into the buffer. If the client is disconnected, the socket is closed, removed from all set, and also removed from all set. Add declare removed from all set. Nice. And then set to -1 because the client is disconnected. And echo server data is echoed. Again, this is a echo server, basically data is echoed using right. And then after that, exit conditions D and ready becomes account if ready is equal if already script is a process and ready is equal to 0. Breaks out of the loop to avoid unnecessary checks. And then clean up the listening socket FD is closed. After that, you can just close the listen FD. Um, nice. Because we already closed the sock FD here, which is just the con FD if the connection is gone. Amazing. Key features non-blocking multiple. The key features is non-blocking multi-client handling. Nice, because non-blocking, well, yeah, it's basically the select system call is blocking until, well, doesn't return until whatever is there. Hmm, I don't know why it's called non-blocking, but interesting. So the server handles multiple clients simultaneously using select without creating separate threads or processes. And so the server handles multiple clients simultaneously with using select without creating separate threads or processes. Okay, this is the main thing. Using select, um, you're basically keeping log of which client is available without creating separate threads or processes. Dynamic client management uses an array to track active clients, free slots for new connection, and client is resilience, handles errors, and accept read and other operations gracefully with proper cleanup. Nice. Execution flow, initialize the listening socket, start monitoring for connections. So this is the execution flow if you think about this. uh, Initialize the listening socket and start monitoring for connections. You select to wait for new connections on the listening socket. Incoming data from connected clients, process each event, accept new connections, um, handle data from existing clients, clean up disconnected clients, repeat until terminated. Simplified example timeline start. This is the simplified example timeline. It's all the same thing, but yeah. Start, server listens on specified port, new connection, client connects, and the script is added to all set, and client array, clients and data, select detects data on the client socket, server reads the data, processes it, and echoes it back, client disconnects. Select detects E of F, read returns 0 and cleans up. Um, yeah, potential enhancements, dynamic client management, and replace the fixed size array. I think this is not required as of now, potential enhancements, but yep. Okay, that's pretty cool. So let's try to make sense of it again after we've read the what the code does. So is it stuck though? Yeah, man. What's happening? Is it stuck? Let me just let me just let me just again do this. 1 second. How do you delete this? Okay, finally figured it out again. So let's let's resume again. We were here. So basically, let's just go through the code again. So let's just try to code. Let's just try to code this thing again. So not take much time. Just include these statements first. Obviously, this thing is s3io.h, and then include stdlib stdlib.h, include the syssocket.h. You can also include fcuntil.h because we're using time. It's not required, but this is also appreciated, and yep, this is also required. And types.h, types.h, and what else is there? That's done. Select sys select.h. Also, obviously, you need to do this to arpa/inet.h. Also, this net what was it? Net inet/in.h, net inet/in.h, net inet/in.h. Oh, this too. We need this too. That's cool. Now we can do int main int argc char pointer. Do that. Do that. After that, or you can just do define. Well, yeah, max line basically for the buffer, max line 1024. Should be capital max line. Define buffer size. I'm sorry. After that, max lines also you can do 10. That's cool. And you can do global int sock50. You can do global lesson50, actually con50. You can do sock50. You can do max50. You can do n for, I'm sorry, I think that's it. You can do sist number of bytes, basically n bytes. You can just do n. And okay, well, let's go every set r set. Also all set. That's cool. Okay, what was there again? And ready, exactly. So and ready. This you can keep it in the global, but it's fine. Just do this. After that, you can just do the this thing. No willing to type it. I'm just I'll just do this. Okay. After we've defined all of that, and then the client array. That is important to keep track of which is connected. Yep, that is cool. After that, the buffer, obviously. After that, the struct add sock address, serve address, client address. That's cool. And then after that, you're initializing client address, client array to -1 initially, because not this is this, and that is cool. You're doing listen FD, and this is pretty obvious. You're doing socket, you're doing you're doing bind next, basically BLA, or you can just, yeah, before doing bind you have to do memp set, and then a finet. And add any, and then set the port also. Yep, sorry, set the port also. Send port is equal to h2ns a2i arg v1. That is cool. And then you have to do bind. Insane. I have to check if this is less than 0. Then PR bind exit 1. Before doing that, close this empty. Cool. After new bind, you have to listen. For lines. Listen on listen empty. For max clients. Yep. Now if this returns less than 0, then you do PR listen and exit 1. Probably close the listen empty. 2 is just a good practice. After doing that, you have to accept, which is you just have to print f that this basically. Yep, you have to do this listening on this port. Pretty much cool. And then initialize the FD set, which is FD0 basically. Sorry, what? FD0 basically on set, and it's where the meat of the matter comes. So let's do FD0 because there's FD set and all set. You're nulling it. That's even a word, but okay. And then you're adding listen FD. using FD set. And then setting max FD to LSND, that's cool. And then while loop, while loop, while one basically. You're constantly looking to accept clients basically. So how do you do that? Well, um, you can call nready is equal to select system call on on max fd plus 1. Oh, before doing that you have to do r set is equal to also, because it's just a copy of for user content select, and then r set, and then 0, or we can use null, sorry, null, null, kind of do and r set cool. Now pretty much you just do that, just do peer select and then exit one, or you can just do next iteration, which is continue. That's cool. I think that's what it is, right? Oh, break. Damn, bruh. Why? I should be less than 0. Damn it. It should be less than 0. Should be less than 0. Okay. Why though? Okay, it just failed, right? So just to break. Cool. Now you have to do if less than FD is a part of sorry, if FD is set, yeah, what if FD is set of listen FD if listen FD is in all set or R set basically, then yeah, if listen FD is part of the R set, which means that the client is ready, which means that it is ready to, I mean, it is available for accepting connections basically. Then you just do exactly add length. Oh, client length, actually this is should be client length. Just do if con ft is equal to just the same thing. You know the drill. So I'm just gonna copy this thing. Con ft is this, right? Listen fd on client address, client length, and yep. All right. Have we not defined client length? I think we have not. Let's just do that. This should be just sock lengthy, right? Yep. That should be client lengthy, right? Think so. Yep. Right. After that, well, after that we'll you change um the array, the client array for connections, basically that's used for active client connections. Basically, for int I is equal to 0, I is less than max clients, sorry, I plus plus, I plus plus, um, if client length is minus 1, then you do client pick on empty. Exactly. After doing that, break. Yep, break, come out of the loop. That's what we've done here. Super, superb, superb. You now close it? Damn. Okay, after closing that, let me think. Um, after closing that, um, client length connectivity, we should check. No, come out of this loop. Now you just oh yeah, so if after that, um yeah, after that, which means the client is accepted, which means uh you just print out this thing, right? Exactly, you just print out this. For the IP address, use inet n2a, and for port n2hs. Amazing. Yep, after doing that, now if you just do for um, error corrections, basically if I is equal to max clients, then you just have to too many clients and then just do that. But if it is else, then you have to add connectivity to the all set, and if connectivity is greater than max of d, set it to connectivity. Yep. Okay. Okay. So yeah. Okay, that is cool. And new connection to the FD set. Okay, but we're only checking for listen FD if it is ready though in this loop. So it doesn't matter if we do this or not. I don't think I have to check if this is actually needed, but okay. And then do if mine, if after decrementing it, you should check for it if it is less than or equal to 0. That means you just have to go to the continue loop, continue, which is the next iteration. Interesting enough. Interesting enough. Well, that is definitely, you have to continue, not break out of it. Oh well, yeah, yeah, you have to continue. True. And then for check for incoming data. Check for incoming data. Now this again is this kind. You select whichever client is um, is ready, which means that if just do if yeah, so if this SOCFD, if it is less than 0, which means it is not there, but if it is greater than 0, which means you're retrieving the con here. Exactly. And then pretty much this is just the code for that. Perfect code. And then you're actually checking if the SOCFD is part of RSIT again. Okay, now checking if the ConFD is part of RSIT. Okay, which means it is it actually ready to, okay, that's, if it's actually ready to read data from, amazing. Amazing, I have finally got it. Yeah, you're doing n is good read of that, and client disconnected, clear, SOCFD. Yep, client disconnected, clear SOCFD from the all set. Client if I is -1. Else, though, we just do this and then break. Oh well, that's pretty cool. As all code, it's just very much of a common sense. Pretty cool. And then you just do this too. Oh, we have to for loop. We have did that, did that. Loop ends here. And then after that, close less than empty, return 0. Pretty cool. This is not ending. Okay, just end it there and put it here. Okay. Yeah, basically this is what it is. Pretty simple, pretty simple, pretty simple. That's pretty simple. It's pretty good. It's pretty good. That's pretty good. Pretty simple. Should be this. Oh, it should be I. int I again. Int I, we just define it here and it's better. And I just put it here. Yep, that's pretty cool. Maybe probably we will do this again later, but as of now, yeah, that's it for today. Okay, cool. Cool. I'll be back in 10 minutes. See, thank you for